From the moment you wake up and check your phone to when you stream a movie at night, you're living inside this massive, invisible web. That web is the world of computer networks. And in this explainer, we're going to break down how it all really works from the ground up.
It's pretty wild, right? You tap your screen and a photo just appears on a friend's phone halfway around the world. It feels like magic, but it's not magic. It's just networking. And by the end of this, you'll get the core ideas that make it all possible. All right, so to understand something as huge as the internet, we have to start small, like really, really small. So let's just ask the most basic question. What is a network, anyway?
And believe it or not, that's it. That's the whole idea right there. Seriously, forget all the complicated stuff for just a second. If you have at least two devices and they are connected in a way that lets them share something, you have a network. It really does start that simple. This image just nails it. The technical diagrams can look super intimidating, but the caption says it all. At its heart, a network is just a conversation. One device talks by sending information, and another listens by receiving it. That's the fundamental exchange. Okay, so if a network is a conversation, what do you actually need to have that conversation? Well, that brings us to the building blocks, the basic anatomy of any network you'll ever encounter. Every network, and I mean every network, breaks down into two key things: hardware and software. Think of it like a city's road system. The hardware, that's your computer, the cables, the routers, that's all the physical stuff. It's the pavement, the intersections, the bridges. The software, though, that's like the traffic laws and the stoplights, the rules that everyone agrees to follow so you don't have total, absolute chaos. And here you can see that hardware side in action. Those cables are literally the roads for our data. And those little boxes, the routers and hubs, they're like traffic cops at the intersections, making sure every single piece of information gets exactly where it needs to go, whether it's zipping through a physical wire or flying wirelessly through the air. So what about those rules of the road? Well, in networking, we call them protocols. And it's a simple idea. Just like two people need to speak the same language to understand each other, devices need to use a shared protocol so that data doesn't just turn into scrambled nonsense. The most famous set of rules is called TCP/IP. It's basically the universal language of the entire internet. Okay, so we know what a network is, and we know what it's made of. But so what? Why bother? Why go through all this trouble to connect things? Well, because that connection gives us some pretty incredible superpowers. The benefits go way beyond just sending a quick message. It's really all about efficiency. You can share expensive stuff like printers. You can access the exact same files from different computers. You can centralize all your security, and you can make sure your data is backed up and easy to get to. Honestly, it's a complete game changer. And take this as a perfect classic example. Instead of buying a printer for every single computer in an office, a network lets everybody connect to and share just one. It's such a simple idea, but it saves an incredible amount of money, space, and just general hassle. That's the power of sharing resources. All right, now that we have the fundamentals down, let's zoom out. Because here's the amazing part. The same basic principles of hardware, software, and sharing apply whether the network is just in your living room or it spans the entire planet. So networks are usually grouped into three main sizes, just based on the geographical area they cover. We're going to start small with the LAN, scale up to the city-sized MAN, and then go global with the WAN. First up is the LAN, or Local Area Network. This is the one you're probably most familiar with. Your home Wi-Fi, connecting your laptop, your phone, and your TV, that's a LAN. It's local, it's small scale, and it's all about connecting devices that are in one physical place. Now, when we scale up from a LAN, we get a MAN, or a Metropolitan Area Network. This is what you use when you need to connect a bunch of different LANs across a bigger area, like a city or a large university campus. So, for example, a company might use a MAN to link its main office downtown with its factories across town. It's a network of networks, all inside one city. And finally, we get to the big one, the WAN, or Wide Area Network. This connects devices over a massive area. We're talking across countries and continents. And the biggest, most famous, most powerful WAN in existence is, of course, the internet itself. The internet is the ultimate network of networks. So just think about that for a second. We went from two computers just talking to each other all the way to a global system connecting billions of people. The technology scales up like crazy, but that fundamental idea, using a connection to share something, it stays exactly the same.
We've seen how networks connect our devices using hardware and software, right? But that leaves us with a much bigger question. Beyond just connecting the machines, how does all of this technology fundamentally connect us?